When we talk about the future of AI, we often think chatbots, right? Getting better at text. But what if the real next step is AI that doesn't just talk, but actually acts within the digital world?
Yeah, that's the core idea, moving beyond just language generation.
So today we're doing a deep dive into something called Portalgraph.
Mm.
It's a new framework from Portal Labs, and it sounds like it's aiming to build exactly that, a foundation for these autonomous digital agents.
That's right. Portalgraph is essentially a toolkit. It's for creating AI entities that have their own knowledge, their own memory, even their own objectives. It allows them to operate much more, well, independently than the AI we typically interact with now.
Okay, so our mission for this deep dive is to really understand what Portalgraph is, what it might be able to do, and why it could be a pretty big deal for AI's future, and maybe even for our daily lives. Our source is an overview doc from Portal Labs themselves, so let's jump in. At its core, what is Portalgraph?
Okay, let's unpack this. Fundamentally, Portalgraph is a graph-based simulation framework. Think of it like setting up a digital stage, almost like, I don't know, building the world in a complex simulation or strategy game.
Okay, like a virtual environment.
Exactly. But here's the key difference. Instead of you controlling everything, you have AI agents living, acting, existing within this environment. And these agents aren't just waiting for your prompts. They have their own internal model of the world, their own goals within it.
So they're not just reactive.
Precisely. The big insight here is moving from purely reactive AI to AI that can proactively pursue goals within a defined space. It's about agency.
Right, so it's not just processing a query and giving an answer. It's like you said, creating a space where the AI can sort of live and work.
You got it. And the critical concept, the thing that makes it different, is what some researchers call situated cognition. The agent isn't just, a detached brain. It's embedded in this environment. It perceives things, it remembers past states, it makes decisions based on its goals within that context.
Okay, situating cognition. So the environment shapes its actions.
Yes. Portalgraph itself acts as both the world model, that's the digital map of all the objects, the relationships, the rules, and the execution environment. That's the actual place where agents take actions and interact with that model.
Can you give an analogy, maybe?
Sure. Think of the world model like a super detailed blueprint of an office building. It shows every room, every desk, every connection. The execution environment is the actual building where digital people, the agents, can move around, use tools, interact with things based on that blueprint.
That helps. So within this digital world, what can these Portalgraph agents actually do? What are their main capabilities?
Well, there are several key ones highlighted. First off, memory management. This is a big one. Portalgraph lets agents manage both long-term and short-term memory as part of how they operate.
Why is that so significant?
Because it allows them to learn and hold on to information over time. That knowledge then shapes their future actions, their decisions. It's about persistence. Think about an assistant that remembers your preferences not just from the last 5 minutes, but from weeks or months of interaction.
Yeah, that's definitely a step up from the often goldfish-like memory
Yeah.
of current assistants.
Yeah.
Okay, what else makes them different?
Goal-directed planning. This is crucial. Agents operate based on objectives you set for them. So instead of you giving step-by-step instruction,
Like a script.
right, instead of a script, you give them a higher level goal. Say, organize my schedule for next week. And the agent figures out the necessary steps within its environment to try and achieve that.
Okay, so it's less task-based and more autonomous in reaching an outcome.
Exactly. The insight is that shift towards goal-oriented autonomy. It's like delegating a project, not just a task list.
Got it. So they have memory, they have goals. How do they actually, understand and interact with this virtual world they're in?
That brings us to environmental awareness. Agents in Portalgraph perceive and react to changes in their simulated space. This goes back to that situated cognition idea. Their intelligence isn't static. It emerges from constantly interacting with their surroundings, sensing, adapting.
So if I drop a new file into a shared folder that the agent is monitoring in its environment,
It might notice that change and adjust its plans or actions accordingly. Yes, the context matters.
okay. And what was the last key capability?
Tool use and API integration. This is vital for real-world utility. Portalgraph agents aren't limited to just manipulating things within the simulation. They can be given access to external tools, functions, APIs for other applications.
Like what, for example?
So imagine an agent monitoring your calendar, which exists as an object in its scene graph, its environment. If it detects a conflict based on a new email it also sees, it could potentially use a scheduling API, an external tool, to propose a new meeting time.
All without me explicitly telling it step by step.
Potentially, yes. The insight is extending their reach beyond the simulation's boundaries.
Okay, I'm starting to get a better picture of what these agents are.
Yeah.
But how does Portalgraph actually, technically, make this happen? What's the architecture look like?
Right, the architecture has a few core pieces working together. First, there's the scene graph. This is really the foundation. It's the digital environment represented as a network, a graph of interconnected nodes.
Nodes B.
Nodes can be objects, like a document or a calendar event. They can represent abstract concepts like tasks or even actions themselves. These nodes have properties and define relationships between them. Think of it like a very structured, machine-readable description of the world the agent lives in.
A map of everything and how it connects.
Okay, then you have the agent loop. This is the fundamental cycle each agent goes through continuously. It's perception, memory, reasoning, action, repeat.
Perception, memory, reasoning, action.
Exactly. The agent perceives its environment via something called the observation layer. We'll touch on that. It accesses its memory, both short and long term. It reasons about the situation, often using an LLM, to decide what to do, and then it takes an action within the scene graph.
And that action changes the scene graph, which then affects the next perception cycle.
Precisely. It's a continuous feedback loop.
You mentioned LLMs, large language models. How do things like GPT-4 or Claude fit into Portalgraph? There's a bridge to LLMs.
Yes, and it's absolutely critical. Portalgraph cleverly integrates with LLMs. It uses their power for understanding natural language, for reasoning, for planning. So when an agent needs to interpret a complex goal given in plain English, or figure out the best sequence of actions, or even generate a natural language response, it can call out to an LLM via this bridge.
So Portalgraph provides the structure, the world, the memory.
And the LLM provides a lot of the sophisticated cognitive heavy lifting, the reasoning engine, you could say. It connects the structured world simulation with the power of modern language AI.
That makes sense. It avoids reinventing that complex part.
Yeah.
Now, what about temporal memory? How is that different from the memory we discussed earlier?
Good question. Temporal memory is specifically about storing context over time. It's the mechanism that allows agents to build up knowledge, remember past interactions, analyze trends, and exhibit consistent behavior across longer periods. Without robust temporal memory, an agent might react well in the moment, but wouldn't really learn or adapt based on historical context. It's key for tackling complex, evolving tasks.
So this is what lets an agent, say, track a project's progress over weeks and understand how things have changed.
Exactly. It provides that historical depth, that persistence of understanding.
Okay. And the last piece you mentioned was the observation layer.
Right, the observation layer. This introduces a really important concept: partial observability.
Meaning they don't see everything at once.
Correct. Just like us in the real world, Portalgraph agents typically only perceive a limited slice of their environment at any given time. They don't have a god's eye view. This limitation forces them to be more active in exploring, seeking information, and making decisions based on incomplete data. It makes their behavior more realistic, more adaptable.
That's fascinating. It adds a layer of uncertainty they have to deal with. Okay, this architecture sounds powerful, but maybe a bit abstract. Let's bring it down to earth. Where could we actually use this? What are the real-world applications?
Yeah, this is where it gets exciting. One major area is productivity automation. Think about an agent living in your digital workspace, seeing your calendar, your emails, your documents, maybe your project management tool like Jira or Asana.
Okay.
Because it has context and goals, it could potentially do things like proactively reschedule a meeting if it sees you've been double booked from an email it just processed. Or it could pre-fill parts of a weekly report by pulling data from various sources it has access to. It could summarize complex email threads, flag anomalies and data it's monitoring, maybe even delegate simple subtasks to other, more specialized agents or systems.
So it's not just rule-based, if this, then that. It's understanding the context of your work.
That's the promise, a deeper level of proactive, context-aware assistance. Imagine how much time that could free up from routine admin. It could really change daily workflows, letting you focus on higher-level stuff.
That's a very compelling vision for, well, knowledge work. What about bigger scale?
Yeah.
Industrial applications?
Absolutely. Another huge potential area is enterprise digital twins. Companies could use Portalgraph to build detailed dynamic simulations of their operations. Think supply chains, manufacturing floors, complex infrastructure.
Like a virtual replica?
Exactly. And within that replica, you have agents simulating processes, predicting bottlenecks in the supply chain, maybe identifying potential equipment failures in a smart factory before they happen, or monitoring a power grid for anomalies. The benefit is optimization and foresight in really complex systems. It's about managing complexity dynamically.
So, active agents inside the simulation, finding problems and suggesting solutions, not just a static model.
Precisely. And moving to something maybe more fun. Gaming and NTC evolution.
Ah, smarter game characters.
Potentially much smarter.
Mhm.
Imagine non-player characters, NPCs, in a video game that actually learn from how you interact with them. They could develop their own long-term goals based on past events.
Like an NPC remembers I cheated them in a card game and holds a grudge.
Exactly. Or maybe they form alliances with other NPCs, or their personality subtly shifts based on the player's actions over dozens of hours. And critically, this behavior could persist across game sessions.
That would make game worlds feel incredibly alive and unpredictable. Less like clockwork, more organic.
That's the idea. A new level of emergent, persistent behavior in virtual characters, leading to much more immersive experiences.
Okay, productivity, industry, gaming. What about more personal applications? Education, maybe?
Definitely. AI tutors and companions are another fascinating possibility. Portalgraph could enable educational agents that are truly interactive and goal-driven. Imagine an AI tutor that adapts to your specific learning style.
How so?
It would remember which concepts you struggled with in past lessons because of its temporal memory. It could then tailor explanations, create personalized practice problems, and set challenges that are just right for you. It's not one size fits all.
A genuinely personalized learning journey.
Right. And similarly, AI companions could learn your preferences, your routines, your interest over long periods to offer more meaningful interaction and support. Deep personalization based on long-term memory and context.
That's powerful. So stepping back from these specific uses, what's the bigger picture here? What are the longer-term implications if frameworks like Portalgraph become widespread?
Well, if we extrapolate, we start thinking about autonomous ecosystems. Imagine complex digital environments filled with many agents interacting not just with humans, but with each other, collaborating, competing, negotiating to achieve individual or collective goals.
Like a digital society of AIs.
Sort of. You could potentially simulate entire economies this way, or complex ecological systems. Or think about coordinating swarms of autonomous robots for things like logistics or disaster response. Maybe even decentralized platforms where different agents offer specialized services.
That sound complex and potentially unpredictable.
Definitely. It opens up huge possibilities, but also significant challenges. Another implication is the idea of persistent AI workers. Because these agents can maintain context and learn over long stretches, they could operate continuously. Imagine an agent managing your personal cloud storage, organizing files intelligently based on your long-term habits.
Or running aspects of a business process.
Exactly. Operating a CRM system, continuously learning customer interaction patterns, maybe optimizing user interfaces in real time based on observed user behavior. It's a shift towards AI that's always on, always learning, always working in the background.
The line between a tool and a sort of digital colleague gets blurry there.
It does, and related to that, Portalgraph could be incredibly valuable as AGI testing grounds.
For artificial general intelligence.
Yes, as we try to build more capable general-purpose AI, we need sophisticated environments to test them in. Portalgraph offers that controlled complexity. It has built-in challenges like partial observability, the need for long-term planning, dealing with other agents, and you can clearly measure performance, adaptability, learning over time. It's like a virtual obstacle course for advanced AI development.
Sandbox to see how close we're getting and where the gaps are.
Precisely. But all this potential also brings us squarely to AI governance and ethics.
Yeah, I was wondering about that. These sound powerful.
Extremely. With autonomous agents operating over long periods, new challenges arise, like alignment. How do you ensure an agent doesn't drift from its intended purpose over time, especially as it learns and adapts? Its goals might subtly shift in ways you didn't anticipate.
The rogue AI scenario, basically.
Well, maybe not that dramatic always, but certainly unintended consequences. Then there's transparency. If an agent makes a critical decision after weeks of operation, based on its complex memory and reasoning, how do you trace why it made that specific choice? Explainability becomes much harder.
The black box problem, but on a longer time scale.
Exactly. And think about memory tampering. If an agent's memory stores its understanding of the world in its past, what are the risks if that memory could be maliciously edited or corrupted, either by external actors or even other agents?
Wow, yeah. That could completely derail its behavior or be used for manipulation.
These are critical questions we need to grapple with as this technology develops. Ethics and governance aren't afterthoughts here, they're fundamental.
Absolutely. So, alongside the potential, what are the main roadblocks or challenges facing Portalgraph and similar frameworks right now?
There are definitely hurdles. Scalability is a big one. Running potentially thousands or millions of agents, each with memory and complex reasoning, within detailed simulations. That requires massive computational resources. We need efficient infrastructure.
Makes sense. What else?
Standardization. Right now, there isn't really a widely accepted standard for building these kinds of agent environments. There's a risk of fragmentation, different incompatible platforms, which
Hmm.
could slow down progress.
Everyone building their own silo?
Kind of. Security, as we touched on, is paramount. Persistent autonomous agents could become valuable targets for manipulation or hacking if not properly secured.
Especially if they control important systems or data.
Exactly. And finally, human AI collaboration. How do we design interfaces and interactions so humans can effectively understand, guide, trust, and collaborate with these potentially very complex agents? We need ways for agents to explain their reasoning, justify their actions, and for humans to provide meaningful feedback or override them when necessary. That interaction design is a huge challenge.
It's not just about building the tech, but how we integrate it safely and effectively. Okay, just quickly, how does Portalgraph compare to other things people might have heard of in this space, like AutoGPT or others?
Good question. It helps to position it. AutoGPT and similar projects were early explorers in chaining LLM prompts for task automation, but they generally lack that deep environmental awareness, the scene graph, the persistent memory in the same way. They're more about sequential task execution.
Less situated cognition.
Right. Then you have things like the Stanford Simulacra project, which focused heavily on simulating believable human social behavior in multi-agent environments. Perhaps less emphasis on direct productivity tasks.
More social simulation.
Yes. And platforms like Meta's Habitat are primarily focused on training embodied AI, like robots, in realistic physics-based simulations, often for navigation and interaction with physical objects.
So more robotics focused.
Correct. Portalgraph seems to be aiming for a more general-purpose niche, combining that structured world modeling, the scene graph, sophisticated memory management, goal-directed planning, and LLM integration, applicable across productivity, simulation, maybe gaming, and more. It's trying to provide a broader foundation.
Okay, that helps place it. So, to wrap up our deep dive on Portalgraph, what's the main takeaway for listeners?
I think the key takeaway is that Portalgraph and frameworks like it represent a really significant shift. We're moving towards AI that's more autonomous, more proactive, more situated in digital environments. By giving agents memory, awareness of their surroundings, and the ability to plan and act based on goals within these structured worlds, it really does open up a vast new landscape of possibilities, from changing how we work to how we play, and maybe even how we simulate and understand complex systems.
It's a glimpse into a future where AI agents aren't just tools we command, but maybe more like persistent entities we collaborate with. So, as you think about all this, consider the profound implications. What does it truly mean to have AI agents that can learn, remember, and act independently over days, weeks, maybe longer? How might that fundamentally reshape our digital world and maybe even bleed into the physical one? And perhaps most importantly, what are the big questions about safety, ethics, and control we absolutely need to be asking now as these foundations are being laid? That's something to really mull over.